This is about tides. Here we have the Earth, and over here is the Moon. The relative sizes are actually to scale between the two. The Earth with a diameter of 8,000 miles, the Moon with a diameter a little bit more than 2,000 miles. The actual distance between the two is not, as it says here, the actual distance between Earth and Moon should be 10 times as much. So the Moon would be actually out of the picture here. But of course we would like to have it in here, so we're faking that somewhat. But I can move this blurb here out of the way, out of the picture, because we just looked at it and it would be just in the way now as we look at tides. Okay, the Moon is exerting gravitational force on every point on the Earth, and in turn the Earth is moving, exerting a gravitational force on the Moon on every point. But we're interested in what happens to the water bodies on Earth, so we're just going to look at the gravitational forces that the Moon exerts on the Earth and not vice versa. As I said, because we're interested in what happens to the water bodies on Earth. Okay, so here's the gravitational force of the part of the Earth that is closest to the Moon. Here's the gravitational force of the Moon exerted on the Earth itself, and notice that this one is shorter. Which makes sense because it's further away, and that's what the gravitational law says. It depends on the distance. Here is the gravitational force that is exerted on the other side of the Earth, again because it's further away. Of course these arrows are exaggerated so that we can actually picture them here. Here is the gravitational force exerted towards the bottom. Notice it's about the same length here because it would be the same distance, but it's at an angle because it's pointed towards the Moon. Here is the gravitational force exerted on the top of the Earth, or in this part here in this picture, the top, again at an angle. So these are the forces that are exerted on each part of the Earth. So what the Moon is doing is it's pulling this part here the most towards it because it's closest. This part here is pulled less towards the Moon because it's further away. And this part over here is pulled yet less towards the Moon. And we can already see that now we have tidal bulges on the side closest to the Moon and furthest from the Moon, because we have less force here than we have in the middle of the Earth, and more force here than we have in the middle of the Earth. So that's basically the explanation for tides. If we take this a little further, we can do the following. We can take this force here that is exerted on the Earth and subtract it from each of the other arrows. So I'm going to do that. Subtracting means I turn the arrow around. So as I subtract here, I get this net, and now I can move this one out of the picture. When I subtract this one here, I get this net. Again, I can move this out of the picture. When I subtract this one over here, I'm going to get this net. And again, I can move this out of the picture. When I subtract this here, I get this net force. And again, I can move this out of the picture, and now I can with this one on the picture as well. So if I take it a step further, then these are the forces that we would have on each part, on each of these water bodies, and then we can see that, well, here we have the water, so to say, being pulled away from the Earth over here as well. Remember the earlier picture we had? The reason is the difference in the gravitational force depending on the distance to the moon. Here we have components that pull the water towards the Earth, and then what the water likes to do is it actually likes to flow over here. So we can take these slabs of water and just turn them. And same thing over here. There we go. I know this looks a little bit funky actually, more so than what I intended. Respectively, actually, these errors I could leave there, I guess. And then the Earth rotates underneath these tidal bulges, so different parts of the Earth get a tide, get a high tide, and then different parts get a low tide. So if I start this over again, then we would have here a high tide. 6 hours later we have there a low tide. Another 6 hours later we have another high tide, so that's a total of 12 hours. Another 6 hours later we have another low tide. Another 6 hours later, so 24 hours total, we have a high tide respectively. In the meantime, in those 24 hours, the moon would have orbited some, so actually the slabs of water are not directly pointing, are not exactly here anymore, but they would be kind of here, and these would be kind of here. And of course this one here would have to be a little bit moved around. There we go. There we go. And that's why we don't have tides exactly every 24 hours, or exactly every 12 hours, but every 12 hours and 25 minutes respectively when we go from one high tide to the over next high tide. We would have them every 24 hours and 50 minutes because the moon has orbited a little bit in the meantime.